so some administrative stuff before we get started on our exercise today. Before we talk about some of the homework, and then get started on our exercise today. So first off, our exam is currently scheduled for October 3rd, which is next week. I've already sent out an announcement email with practice problems, which I will go over on Thursday. It will be primarily covering for loops and turtles. But again, more details will be coming on that, more explicit details about that kind of thing. But it primarily covers most of what you need through Lab 4 and 5. Speaking of Lab 4 and 5, I've noted, as if you saw on Discord, I was pointed out to me that the due date for the assignment was this Friday. I don't know how that happened. It should be it. So I extended the amount of time that should have, because that should be. I try to make the due date around the same time as the exam. So it's now currently set to be due Wednesday. That one. I'll be fixing the other due dates as need be, but for right now, that one's been pushed back. Yes? Next Wednesday. I wouldn't move it up. That's kind of I think it's called, and I'm sorry, I just need to double check my notes here, a jerk move to move the due date up. Regardless, so, take that, I guess, breath of relief there. So, if you think that the due dates are maybe a bit aggressive, again, this is the week to let me know. In total, we have about 8 assignments overall, so, and those take up about the first 10 weeks of the semester. And then before we transition to doing our before we transition to working on the final project. So just keep in mind that for at least for this first exam, it will be in this classroom. If that does not seem feasible for some reason, like the mechanics and logistics of that and taking that on Canvas don't seem feasible, please let me know. I mean, last semester I did the exams in the lab, but that was because I only had labs on 2 days as opposed to pretty much every day during the week. I think the labs are scattered all throughout the week, so it's a bit that makes it a bit tricky to schedule. So easiest to give everybody the same amount of time to study for it and the like. All right, so also was getting a lot of questions on Discord about this, about some of the problems in Lab 4 and 5. Specifically, the questions about these drawing functions. People see, draw squares, very straightforward for most people. Drawing a row, again, that's fairly straightforward. We just write a for loop, right? To do that, we write a for loop that draws a certain number of squares. Ideally, we don't want the turtle to end here. Instead, it's easier if you get the turtle to end here. I really should update that PDF, but trust me when I say that the output is easier if you let your turtle end here. Okay? End where you started. Regardless, either way is correct. Now, draw grid, right? How do we finish? What is essentially draw grid? What do we use to do draw grid? Anyone? We use a for loop, and what do we call in the for loop? Draw row. Yep, we call draw row. This is a bunch of rows. So if we want to show a square of a certain size, for instance, this is a 5 by 5 grid. So this would be simply drawing 5 rows, a for loop that runs 5 times, right? So not too bad. Now the one that seems to be giving people a lot of trouble is the stairs. Now the stairs is actually just a minor modification of the draw grid, because each of those stairs, each of the levels of the stairs is a row. It just happens to be a different length, right? This is a length 1 row, this is a length 2 row, this is a length 3 row, length 4 row, and a length 5 row. So if you look at it that way, then it should become a bit clear about how you need to handle this, right? The amount of squares in the rows varies. Hint, hint, nudge, nudge, wink, wink. So the amount in the row varies from each line. So again, what you're doing here is making just simply a change to how the for loop runs in draw grid. Okay, any questions on that? Yes? The function, what? Well, the idea here is that you have this draw square function, and then draw row calls the draw square function, and then draw grid calls the draw row function, which calls the draw square function. So you don't have to have like a million nested loops. So this is also why I say you should probably do all the turtle ones, these drawing ones, in the same file, so that you can easily call them and you don't have to copy paste them a bunch of times. Other questions? But also to answer your question more generally, you're allowed to add more functions however you want. I mean, like, if you want to, you're allowed to use stuff, if it's in Python, you're allowed to use it. Okay? But what I'm talking about is that if you want to break up your program into more steps, because that's easier, you're allowed to break it up into more steps by creating more functions. No, this is just the 5x5 here is an example. This one's an example, right? So here this takes in a turtle, a height, and a square size, and so this is showing what the output should look like if you do this function call for 5 with size 50. So a height of 5, which means 5 rows, and each square is size 50, right? So if we put in 6, we'd expect a 6th row over here. So it should, be flexible. Other questions? All right. So overall, I see a lot of people making good progress on it, asking for questions. I'll remind you that when it comes to asking for help, that you don't, if you have finished the program, don't share your code with other people. But if you need help, feel free to share your code with other people. If you're the one who needs help and you're like, I don't know what to do, that's okay. Sharing your code and saying, hey, can you help me fix this? Or can you give me pointers? That's okay. But sharing the answers, you're not going to be able to learn you're not going to be able to make the mistakes to learn, and therefore you're going to have difficulty when we finally get to the exam. Okay? All right. Other questions? Okay. So what we're going to be doing is we're going to be covering more of our exposure to lists today. So this is going to be module, let's see. So again, I have to adjust the weekly schedule here because we're doing the exam in class. We'll do our leap year exercise. We'll most likely end up doing our leap year exercise. Not most likely. We will end up doing this leap year exercise that I have next Thursday, because I'm not gonna deprive you of that torture. Leap years are one of those things that most people think they know all the rules for it, but actually the rules tend to be a lot more difficult. But right now we're going to be working on Project 6 in the book, so you can find that link over here. I'll also drop this link in Canvas. In Discord. Okay, Discord. Okay, and then also, again, if you just want to get there from Runestone, log on to Runestone, go to our class, open up the textbook, and scroll all the way down to project 6, computing statistics with Kiva. Is anybody familiar with what Kiva is? All right, Kiva is a nonprofit that came out when I was around the time I was in school and doing my undergrad. What it is that it's a microloan service. There's a lot of people who need loans for small things, but not necessarily big ones, but can't secure credit just simply because of where they happen to be located in the world. So again, these are loans, so they do get paid back, but the idea here is you donate money to Kiva. Generally, the smallest increment is $25. And then you loan it out to a specific project that you decide to, and then they'll pay back the money, and then you can reloan that amount of money, that same amount back to another person. So it keeps going around. So here in education, financing for university, refugee causes, technology causes, so all sorts of different things. Some of them are large, some of them are quite small. But the idea here is that this is a nonprofit that helps get people loans that they normally couldn't get. Okay, now as you might imagine, if they've been around since 2005, they have tons of data to sift through. And so here we've got a subsection of a small snippet of their data, and it's been loaded into lists. But right now we'll look at it in terms of a table. This has some data, and we're going to look at some basic statistics that are used in data science. Just some very basic stuff. We're talking about calculating the mean, the end, and the like. Okay? So here we have an ID, right? We have a loan ID, which we're not really going to use, but that's simply the ID of the loan. Okay? Then we have 5 fields we actually do care about. The amount that was the loan amount, the country name, so the country where that loan was given, status. So actually we don't care about this one because they're all funded, so there's no need to check that. Time to raise, which is given as a float. So what do you suspect the unit for this one is? Second seems like a pretty good guess. Millisecond seems a bit too small. Hours is just hilariously long, and minutes feels that'd be a lot too in minutes. Seconds seems like a good guess. And then number of lenders total. So in other words, how many people total raise this money? And you'll notice that there's a lot that we cannot tell from this data. For instance, this data doesn't tell us who made what loans, who got the loans, how much each individual loan was. This is a lot of aggregated data because this kind of aggregated data is safe to release. There's specific rules that govern data collection, and especially when it comes to interactions with other human beings. You can blame Stanley Milgram for that one. Actually, it's mainly the psychologists we can blame for data collection on human beings here. Psychology 101 has some wild stories. So, anyway. So here we've got the loan amount, time to raise, country name. So all these columns are stored as lists. Now there's a lot more advanced tools for dealing with data in Python. Using a Jupyter notebook is one of the big tools here. Using NumPy for statistics. The big programming languages for statistics, as far as I understand, like the ones that are open source and free, are R and NumPy for Python. So those are pretty big. I think like SPSS is also pretty good, but I haven't worked with that one myself. Now generally when things get that big, we need to have a bit more advanced tools and really think about how we're processing through stuff to make sure we're processing in an optimal manner. But it says this is a random sample of something that contains 1.4 million rows, and I think we have like 40 rows in here. Okay? So right now, though, because this is like, again, pedagogical, we're going to be just working with us. We're just going to be representing them very simply, which is that each column is its own list. And here's the lists. Just go ahead and hit save and run to make sure you've interacted with this. But the idea here is that these variables will exist in all the other code blocks, even though we don't define them. It's just kind of being silently loaded in the background for you. So for instance, if I go over here to the bottom one and I type print len of loan amount, you don't need to type this out, I'm just showing as an example. Even though I haven't defined loan amount, it prints out an answer for me. It prints out 25 over here because loan amount has been, again, loaded in the background, so I don't have to keep constantly copy-pasting these into our files. So let's take a look at these, though. So notice that loan amount 1250, 500, 1450. Okay, Azerbaijan, El Salvador, Bolivia. Let's go scroll back up just so we understand how this is working. 2050, 500, 1450. Azerbaijan, El Salvador, Bolivia. So this is all, so basically these are all being stored in each of the order. The loan amount goes through in order this way. Azerbaijan, all the country names, all are stored from the top bottom. Same with the time to raise. In other words, everything that's part of the same row has the same index, right? All the stuff for this first loan is at index 0. This loan is at index 1. This second loan is at index 2, right? Does everybody understand what I mean by when I say index? Hopefully you've been keeping up with the readings, okay? Again, index is just simply the slot that we're storing it in. So here, and we start at 0. Okay, so that'll be useful because when it comes time to like basically say, okay, which country got the biggest loan or something like that, we just simply find the appropriate index and look at the same index in country name. All right, so we're going to go through these basic questions, and I think that these generally take up most of the time here. So what is the total amount of money loaned? So how much was the total amount of money loaned? That's our first question, and then we'll look at other questions like the average loan amount, what was the biggest and smallest loans, which country got those largest and smallest, what's the variance, and what is the average number of days needed to fund a loan. So these are kind of things we can look at. So let's go ahead and look at the first one, which is compute the total amount of money loaned and store it in loan total. Okay? And you'll notice that we have some unit tests going on in the background to check your code. So we want to calculate this amount. We need a loan total variable, and we want to store that appropriate amount in it. So go ahead and take a few minutes to tackle that one. That one is, again, calculating the total amount of money loaned and stored it in loan total. Right? That means we'll be wanting to work with the ones that actually details with, like, again, the amount of money we have, which is loan amount. All right, so take a few minutes for that. And pause. So, okay. So I believe that this is, let me just see. Is this where we start getting, no. Okay, so there's a couple different ways to do this one. There's the way I'm expecting you to do it, and then there's the way if you've been reading ahead or been paying close attention to what I've been saying. So first off, we need a variable called loan total, right? The problem says compute the total amount of money loaned and store it in the variable loan total. So let's go ahead and define loan total first, equals to 0. And what we need to do is that we got to take all these values from loan amount and add them up into loan total. That means this is a running sum problem. All right, so to do a running sum, what we do is we iterate over the collection for I in range loan underscore total, so not loan total, loan amount, loan underscore amount, which is all the loan amounts. Personally, I would have called this loan amounts, pluralized it, because it's, it's not a single loan amount, it's multiple loan amounts, but some people, for some people it clicks better to have it singular, that each item in the collection is a loan amount. But so let's go ahead and instead for I, I'm going to give it an actual name for amount. You can call it whatever you want. You can call it I or whatnot, but I'm going to call it for amount in not range. Jeez. That's what happens when you talk and type. For amount in loan amount. Loan underscore total is equal to the current amount we have plus the new amount that we're looking at. And that's about it. So here we go. See loan total is equal to 0. For each amount in the loan amount list, we take a look at that amount, add it to what we have, and store it as the new running sum, right? So for each of these amounts, we look at the current total of the running sum, add in what we have, compute that, and store it in our running sum. I don't need to print it out here because all the directions say is to just simply store it in the variable. So I could print it out if I wanted to, but it's just checking. And so it says you need to use the loan total variable, which we do. Here it says actual value, expected value, so it checks the amount that we're adding. And then it says use the accumulator pattern to add up all of the loans. That's just their way of saying it's a running sum. And then this last one over here, you may not use sum. This is to prevent you from missing out on writing for loops, or to prevent you from skipping a step in pedagogically, right? Because would totally be valid in most situations to just simply do this. Loan total is equal to sum loan underscore amount. And if your first instinct was to do that, awesome, great. That means you really got a handle on Python. Unfortunately, we have pedagogical reasons to not do that, right? And in fact, I think it's aggressive enough that that if I just even comment it out, it will not like it. So we'll see. Let's see. Yeah, it doesn't even like it when it's commented out. So, because what it does is read your code and checks to make sure you didn't use sum there. But if you ended up using sum and that was your first attempt and you would have gotten it correct otherwise, awesome. On an exam, that's what I would have cared about, that it worked. There's multiple ways to do things in Python. One other way to do things, which may feel more natural if you're coming from a different programming language, and this is a bit more verbose, but I'm going to do it right now because it will help for later sections, is to instead look at everything through the index. Right? Loan total is equal to 0, for amount in loan amount. So instead, what we're going to do so here I'm going to comment this out and write for index in range 0 to len of loan amount. So the list loan amount has 25 entries in it. I was wrong about it being 40, so it's 25. Which means all the indexes the valid indexes are 0 up to, but not including 25, so 0 through 24. So if we iterate through 0 and 24, we can access each loan amount individually and pull it out. Now, this is not the way I would suggest doing it, but if you tried it this way, that's also okay. It's just a bit more verbose, but I want to just emphasize the whole way it works to extract a value from a list when you've got the index, which is we would just simply say amount is equal to loan amount loan amount at that index, grab the loan amount from that index, and then we just simply grab the same line we had up here. Notice that basically we're just kind of adding an extra step in here, but it would still give us the same answer. It just adds an extra step over here. This is the way that a lot of other programming languages work, where it doesn't necessarily give you a for each loop. Instead, you have to iterate over a value, and that's typically a numeric value. Okay? But again, any of those ways that I showed before would have been fine on an exam. I don't care how it works so long as it gets done. Okay? Now, here we go. We can use that answer. So now, let me go ahead and share that answer just in case you missed it. So share code. And of course, you can just access that by reloading the page if you need to. So let's look at problem 2. Compute the average amount of money loaned and stored in the variable loan average. And just to be clear what we're talking about here, we have this list of numbers, loan amount. I want the mean value of that list. I want to average up, I want you to calculate the average value, the mean of that list loan amount. How do we calculate an average, first off? This is not a trick question. How do we calculate an average? So add them up and divide. So we add all the values up, and what do we divide by? The number we had, right. The number of values we had. So if I add up 10, so if I'm trying to find the average of 10 different values, I add the 10 values up and divide by 10. So here, that's basically what we're going to be doing here. As a rule, I wouldn't necessarily, even though I just said that the length of the list is 25, I wouldn't hard code that in, because that makes the code, that's a bad practice. Instead, what I would do is I would figure out how long the list is by using the very awesome len function. So I love the len function because in Java, it is dot length, no parentheses, to figure out the length of an array, dot length with parentheses to figure out the length of a string, and dot size with parentheses to figure out the size of basically everything else. Whereas in Python, it's just the len function. So, love it. Okay, so go ahead and work on computing the average. Obviously, the previous one is going to help a lot here. I just want to make a quick point about brackets. Like when I've got a function like loan amount, when I've got a list like loan amount over here, okay, and I want to get the 5th item from it, right? I would write, if I want to get the item from index 5, I would use the brackets. But why am I using brackets here? Well, in mathematics, I'd be basically doing a completely different operation. I'd be doing a subscript operation, right? If you remember from working with arrays and matrices, from matrices and vectors, in whatever class that they tortured you with back in mathematics, right? You've got, so they would give you like here, give me a second. They would give you something like this. You have a matrix A, and you want to get like the second row and second column. You would do 2A2, right, and be in subscript notation, right? Or maybe it's a one-dimensional array. Let's simplify it. It's a one-dimensional array. You want to get the second value in it, so you do A2. But in a computer, we can't type subscripts. So instead, what do? We just simply instead do A, and we use brackets to denote that's a subscript in the same way that when we do exponents, you would use a caret a lot of the time to denote that it's a superscript, right? It just has to do with the fact that a lot of we're working with only a limited character set here. All right, carry on. I just wanted to address that question. So for this problem, just one second. So for this problem, figure out the smallest amount and the largest amount over here. Okay, and store them in min loan and max loan. Okay, so let's just go ahead and work on this first part, and then we'll tackle the second part. Okay? And it says, hint, min and max are built-in functions into Python. And they work exactly like you would hope they. Again, Python operates under the principle of least surprise here, which is to say that if I give, come on, you can do it. If I give Python and ask for the max of 3, 4, 5, 1, 2, 9, 6, it's going to tell me that the biggest number in there was 9. It's the least surprising thing. And if I instead did that as a list, right? Instead of listing them out like that, it still works, right? And finally, again, the least surprising thing here, if I instead do A, B, and C, still works, where it says C is the biggest. Which, if you think about it, I guess since, A comes before B, B comes before C, 1 comes before 2, 2 comes before 3. That is kind of what they mean by biggest. One thing comes after everything else. So, regardless, that last bit isn't useful. I just, again, the least surprising option. Okay? So that one should take basically a very little amount of time. Okay. Yeah, because the false should not be true. Yeah, that's a weird one. We'll go ahead and see what that is, but I suspect it's because I didn't want you to use a for loop in here at all. So, okay. So yeah, a lot of people are making great attempts that I think are correct. If you're getting false, it should be what got false expecting the true. as part of attempting the entire problem. We'll see if that happens to me, and if that does, we'll have to open this up and take a look at the tests. So, okay. This one's probably the most important one of these, right? Because what I want to do here is, first let's go ahead and, first off, it tells you how to do this, right? Without having to use if statements, which is if I want to get the smallest loan amount, the min loan, I just simply say min loan is equal to min loan amount, right? And that will find the smallest amount. Just that gets you min gets you the smallest thing, max gets you the biggest. If I actually had to do this, like go through one at a time, I would probably go something for, again, more amount. What I'd have to do otherwise, if I didn't have access to this, is I'd have to say min loan is equal to 0. Okay? So not equal to 0. I'm going to say min loan is equal to loan underscore amount underscore and then 0. Basically, I'm going to assume that the first thing in our list is the smallest loan. And then I'm going to say for amount so I'm going to check each amount in the loan amount list, if which we haven't really covered too much yet, if amount is less than min loan, so if the amount I'm looking at currently is smaller than the smallest thing I've found so far, that should be our new smallest amount, right? Which again, Python lets you kind of just skip all that. Let me go ahead and I have a suspicion over here, max loan is equal to max loan amount. And there we go. Okay. So the question is, okay, I've got this value over here. So let's go ahead and I will delete these. I don't need them. Min loan is equal to this. Min loan amount. So this gives us the smallest values. And I've got the smallest value and the largest value over here. Awesome. But how do I figure out what index these things are in? How do I figure out where it is? Now, most of the people I saw, they were using the skills that they had, which is I'm going to use a for loop. I'm going to find where this is in the list. And once I find the smallest value in the list, I'm going to keep track of what index I'm at. And once I find it at the appropriate index, I found my thing. But Python's pretty awesome. Let's go ahead and take a look at our textbook. I think our textbook should go into some of these things. I mean, it definitely should. Foundations of Python programming. Right. List. Oh, there we go. The index operator, count and index. So there is a index function, .index, built into a list, which, right, if I'm going to just test it out over here, right, if I've got this list over here, and I'm going to store that in, I'm going to say L is my list, and if I go L.index, if I ask for the index of 2, it's going to tell me what index 2 is at, which is 3. And if we count, index 0, index 1, index 2, index 3. So index answers the question, hey, what index is this thing at, right? So we can actually do this without any additional iteration on our part. Okay, we can do this without any additional iteration on our part, which is, so we've got our min loan, our max loan, and then let's go ahead and call this min index. is equal to the loan amount, right? We're talking about the loan amount here, dot index of the min loan, right? We could call it min loan index if we wanted to be even more specific, but I figure that's enough typing for right now. And then the max loan, right? We just simply change min to max. Okay? So now we know where these things are. Let me go ahead and print those two things, just simply so we can check ourselves in the list. Min, or I'll just simply check myself over here, index, print min to index, and min loan. This print statement's getting deleted in a second, but I'm just simply using it. Index 5 had the smallest loan of $100. So scroll up to our list, we double check. 0, 1, 2, 3, 4, and here it is. The Philippines has a loan of $100. Okay, and it was at index 5. So now, min country is equal to, and now we have to look at this list over here of country names. What is the country name list called anyway? Country name. Awesome. So min country, the country with the minimum loan, is equal to country name min index. Same index as the minimum loan. Max country. Again, using the tools you have is awesome, but Python has some nice, awesome stuff that answers the question for you. And I'm betting that this issue with the true expecting false was just simply checking if you had any if statements or the like in your for loops, in your function. It really wants you to try to make sure you were using the index functions over here. So, but again, we could have just iterated through it. It's pretty nice. And again, on an exam, I don't really care. The exams are very utilitarian with that regard, right? I have multiple ways to do a problem, right? If the questions are open-ended, I accept multiple ways to do it. Shear code. All right. Now, this one is, okay, so this one needs to, yep, here we go. So compute the average number of lenders per loan and store it in a variable. This one, I'm just going to go over it very quickly because we have 20 minutes left, or 18 minutes left, and I did this one. We've already done this one. It's just a different list, right? It's just a different list, which is we want to compute. So we have the num lenders total, which is the number of lenders there were for each loan. And it wants us to compute the average number of lenders. So we know how to do that. We say, so we have the num, we have a running sum, and honestly, again, it's a very badly named function, num lenders total. That's what I would want to use. That's what I'd want to use as my accumulator. So I'll just call this total is equal to 0 for lenders in num lenders total plus equals lenders. And then we do, it wanted average lenders, so it wanted us to compute the average number of lenders. Average underscore lenders is equal to lenders, or not lenders, total divided by the length of num underscore lenders underscore total, right? It's the same exact problem that we solved earlier. It should be. Okay, good. It was the very same exact problem I solved earlier. I was worried. There's always that worry that I horribly misread something and I'm about to humiliate myself in front of the class, you know? So total, right? We do our running sum. We say, hey, let's look at every value we have, and for every value, we will increment total by that amount. And again, the plus equals, all that is just a shortcut for us saying total is equal to total plus lenders, right? That's all the plus equals is. It's just a shortcut. Okay? And as it's pointed out, it's very similar to an earlier problem. It's the exact same problem as an earlier problem. All right. Now compute the total number of loans made to the Philippines and store it in the variable Philippines count. So take a few minutes for this one. This one's actually fairly straightforward if you look up your functions that are built into Python. Or you could use a for loop and an if statement, ostensibly. I have no idea if it wants you to do that. If true, does it let you? Yeah, you can't even get to that point. Oh well. Compute the number of loans made to the Philippines. This one should be fairly short. Okay. This one's actually a one-liner. And again, the hardest part about this sometimes is the spelling. But again, if you misspell stuff, don't feel bad about it. You're talking to a person who in his high school freshman year forgot how to spell the word took. Seriously, the more you look at words sometimes, the more it's like, wait, how is this actually a word? All right, Philippines count. Philippines count is equal to, and then what we've got over here is the total number of loans made to the Philippines. So what we need to do over here is that we're going to look what we're basically asking for is how many rows have the Philippines in them. So over here, we just need to really look at the country name and count how many times Philippines occurs in the country name. All right, so country underscore name, and then we can use the dot count function, which is here in the same chapter with the index, which counts the number of times that something can occur. It's a super useful function. Again, if you use the for loop, no worries. For loop and if statement will get the job done. Okay, but here we can do you can do this and then count, and then here it will matter how we, the casing. Philippines. Okay, and there you go, one variable. Sorry, and here we have one, method that does that. Okay, we have one function that's built in that does this. Now this last one is that we're going to work on today. Don't worry about the level 2 questions, okay, because again, there's only so much time we have. Okay, for each unique country name, print the line that shows the name of the country and the number of loans made to the country, like this. Guatemala 1, because there was only one loan made to Guatemala. For the Philippines, so it should be Guatemala 1, and then Paraguay, however many there were to Paraguay. And then when we get to the Philippines, it should print out 7, because that's how many loans were made to the Philippines. In other words, it's asking, for each of these countries, print out the number of times it appears in our data set. Okay? So, and now what we have got also to help you is that we have a list of the countries, of the unique countries. In other words, we have the list of all the countries that appear in our data set, but here they are listed only once, right? So you don't have to keep track of which ones we've seen before or which ones are currently in it. Here are all the ones that are in it. We only have to look at one each time, okay? So this is the last problem. Take about 5 minutes to work on this one, and then I will come back and finish this one up. But again, we're building off of what we've done previously. so this is our last problem. Okay, so your code, put your code here. So here's our unique countries. Okay, and what we're going to just simply do is go through for country in unique underscore countries. So we just simply iterate through all these names, right, for every country in unique countries. And again, if you're feeling lazy, you could just totally say for C in unique countries or something else. There's no rule against having to type it out, but I like to have my code readable, especially since I'm teaching a bunch of people, you know? So don't be afraid if in your notes to shorten anything a bit, because it is, again, I've done these exercises plenty of times where I'm able to type them. So for country and unique countries, what we want to do is we want to count how many times that country appeared. We have the value, we have the list country underscore name. Okay, country underscore name dot count. Okay, and then what we are going to count is the number of times that country appeared in that. So that should be, so let's go ahead and I'm just again going to use a really over robust name, occurrences. Probably misspelled that, but whatever. Okay. Occurrences, country name account. And then what we do is that we're going to print the country and occurrences. And there we go. So all we're doing is we're just using a for loop over this list and then using the line that we figured out for the previous problem to count it. So for occurrences is equal to country name dot count, print the country and occurrences. And what's really nice about this one is that, yeah, we could have done this one with a for loop. We could have done this previous problem with a for loop. But what would that mean for here? We'd have to do a nested for loop, right? And we want to try to avoid nested for loops a lot because they're harder to read. If you do have to use a nested for loop, sometimes it's easier to make it a separate function and then call that function in. So you hide the fact that you've got a nested for loop. Again, readability is king here. So don't worry about these other questions, although feel free to try them on your own. But remember to interact with these over here. All right? All right, have a great day. Stay dry and warm. It's a bit wet out. And I will see you all on Thursday. I'll take questions, but not demos today.